Hey everybody, this is Mr. Beckstrom, and today we're going to take a look at example or exercise number 3 in the homework for section 4.6. This was requested by a student. So let's kind of go over this, make sure we understand this. It says the function s of x is equal to 3600 divided by 60 plus x, which can also be written as the 3600 times 60 plus x raised to the negative 1. Makes it a little bit easier when we're finding the derivative. This gives a person's average speed in miles per hour if he or she travels 1 mile in 60 plus x seconds. It says use linear approximation to s at 0 to find a person's approximate average speed if he or she travels 1 mile in 55 seconds. And then it asks, what is his or her exact speed? All right, so let's first of all kind of write the linear approximation formula, and we'll do it in terms of s of x here, so it matches this problem. So it looks like, let me make that a little bit thicker there. All right, oops. Okay, so that did not, there we go. So L of x, that's the linear approximation, is equal to our function here. So this is going to be s of a plus the derivative at whatever a we choose times x minus a times x minus a. All right. So in order to use the linear approximation, and remember what this is. This is taking a tangent line at a certain value and then figuring out where the y value is on that tangent line instead of the actual function. And we usually will get a value that's pretty close to what the real value is. So we should get something that's going to be close to actually plugging in the -5 in order to make this work. And we'll talk about that in just a minute. All right, so what we're going to need to do is we're going to need to figure out s of a and s prime of a. So let's start with s of a. That's going to be s of 0 because they're asking us to find s equal to 0. So to s at 0. So we're going to put a 0 in for there, and we're going to see what this function looks like. So this is going to look like 3600 times, and I'm going to use the right side of this, 60, make that a little bit, plus 0 raised to the -1. And this is really just 3600 divided by 60, which is going to equal 60. So that's my s at 0. And notice the next thing we need to find is the s prime at 0. Okay, so s prime at 0 here. That's just going to be the same function here, except we're going to have to find the derivative of this. So let's go ahead and calculate the derivative. And I should have done that first. So let me kind of erase this. So let's first, before we apply the s prime of 0, let's find s prime of a. That means our function at the derivative here. All right. So if we use the chain rule here, and we also use the constant multiple rule where we can just pull the 3600 out. We're going to bring the -1 out front, and then we're going to change that to -2, and then we're going to multiply by the derivative of the inside function, which the derivative of 60 plus x is just 1, so that's not actually going to change anything, but we're going to end up getting -3600 by pulling that -1 out front times 60 plus x raised to the -2. And again, that's just applying the chain rule there. So now we can take a look at s prime of 0. And that's going to be this function here, evaluated at 0. So that's just going to be -3600 divided by, and we can bring this whole thing to the bottom. So 60 squared is just positive 3600. And we're just going to get a -1. All right, so that's pretty much all we need for this. So let's go ahead and apply it. Let me give myself a little bit more room here. Okay, and um, so plugging this in, our x in this case, I should talk a little bit about that a little bit more here. That's going to be -5. Why? Because 60 plus -5 is going to give us our 55 seconds. So that's what we're going to put in there for x. All right. And so the linear approximation formula evaluated at -5. Well, that's going to give us our s of 0, which we said was 60. Oops. Let me 60. Mouse is having a little bit of trouble. Plus our s prime of 0, which is -1, times x minus a. So that's going to be x minus, remember, we chose a as 0 there. So this is going to equal 60 minus x. So that's the, and then evaluating that at -5 is going to give us 60 minus the -5, which is equal to 65. All right, that means using the linear approximation formula to estimate the problem here, which says we traveled 1 mile in 55 seconds. That means that we're going around 65 miles per hour. And then it says to find the exact value. So there, we're just going to use the original formula with a -5. So if we go back to this here, this is the original formula. So if we just stick that into our calculator, we're going to do the 3600 divided by 60 plus -5, so that's 55. 55, and you get 65.4545 repeating. So that means that we were pretty close with our linear approximation there. If you have any questions, please let me know, and I hope you have a great rest of your weekend. Thanks.